So back to my effective number of candidates data here. I'm not going to actually like be calculating the mean and estimate of the sample variance for my 53 variables by hand on the screen for you. I am going to ask Stata to do it. So what I've got here is Stata output from testing that hypothesis that the effective number of candidates, V is just based on votes. That's my way of naming my variables, whether that's 2 or not. And what I want to do is just sort of walk you through how what we see when we ask Stata to calculate some statistics for us, or we ask R to, or any other package that you might be working with, let's connect this kind of output to the ideas that we've been talking about in this lesson and really talking about to some extent all quarter, okay? So what Stata is telling me here is some things I've already told you about the data set that I have in observations. Okay, so again, we're thinking about those as n independent and identically distributed draws of observations, draws of like outcomes for primary elections here. And right away, the first thing that Stata has calculated for me is the sample mean, M sub n. It's added up my 53 values here and divided by 53, and the average, the sample average here is right around 3, a little bit over here. It's also calculated my unbiased estimator of the sample standard deviation. It's added up the squared deviation from the sample average and divided by 1 minus n to get the standard deviation. And then it's remembered to also divide by the square root of n to get the standard error of the mean. Okay, so what I have in this column is my s hat divided by n. Okay, so these are all, Stata is giving me numbers based on the numbers that I gave it. My observations on effective number of candidates in each of those primaries, and Stata is taking that set of 53 numbers and giving me a small number, a small set of figures that are meaningful and that I can use to decide whether I'm going to accept this idea that, yeah, it's okay to more or less think about primaries as 2 candidate races, or no, it's not. Okay. So it's done all of that stuff. It's also calculated the 95% confidence interval for me here. So what is this? 2.676731. It is that sample mean, 3 point something, minus the appropriate t statistic here, which Stata knows because it's got those t tables built in, like it's got normal tables and Poisson and other distributions built in here, and multiply it by the standard error. Okay, so that's the bottom boundary of my confidence interval, and the higher boundary, the 3.32 here, is plus times the estimate of the standard deviation divided by root n. So all that it took to calculate this confidence interval was crunching numbers, and this is what computers are really good at. And what I have here, and the thing that is meaningful, is I have a confidence interval that does not include 2. Okay. So by conventional levels of significance, I can reject the null hypothesis that the effective number of candidates in my set of primaries, which if I was trying to sell this result, I would be arguing the primaries that matter are the ones where there is actually some uncertainty about who's going to win, where it's meaningful about whether who wins is a meaningful decision, because in many of those House districts, winning the primary is uh, the harder election. The general election in many House districts, even when there's not an incumbent running, is often a foregone conclusion here. Okay, so I can, for those primaries, reject the null hypothesis that they're basically two candidate races. So just writing that out, reject the null, that it's mu and c is 2 in favor of the alternative, that is great. Okay, so this is kind of a springboard to send you on to the next class, to 200B, which is mainly going to be about regression. I am guessing that what we did today with confidence intervals and hypothesis tests, most of you guys have seen before in some kind of undergraduate statistics class, or at least you've encountered the lingo in articles that you've read that have used the hypothesis testing framework, which is ubiquitous throughout social science. Two ideas going forward. One is that I wanted to end with this so you could see how these things that we kind of do every day, looking at output from statistical packages and trying to figure out what does this mean for the things we're interested in, how these ideas are rooted in the probability theory that we've learned throughout the course. I'm also hoping that you will be looking forward to thinking about the regression class, because the confidence intervals that you're going to be interested in most of the time are confidence intervals involving not sample means, but regression coefficients. Okay, so the regression coefficient is estimate of one variable's linear effect on another one, and the null hypothesis that you're always interested in when you're running regressions is the null hypothesis that that effect is 0. Okay, and that is, I think, pretty much where you'll be picking up the regression class. Have fun.